Good morning, everyone. Welcome to today's presentation on mineral and energy resources. I'm excited to have you here. Today, we'll be exploring the key resources that power our world and the minerals that shape our industries. We'll look at where these resources come from, how they're used, and their importance for our future. So, let's get started and dive into this fascinating topic. Let's take a quick overview of the different types of energy resources and minerals that play a vital role in our world. On this slide, you'll see a list of various energy sources like tidal energy, nuclear energy, wind power, solar energy, natural gas, and geothermal energy. These are all crucial because they provide us with sustainable and renewable options for meeting our energy needs. We also have a focus on minerals, which are essential raw materials for many industries. For example, ferrous minerals like iron ore and manganese are key for steel production, while non-ferrous minerals like copper and bauxite are important for electrical wiring and aluminum manufacturing. Understanding the occurrence and distribution of these minerals in India helps us appreciate how natural resources are spread across the country. Additionally, you'll notice mentions of non-metallic minerals, rocks, and the hazards associated with mining, because extracting these resources isn't without environmental or safety concerns. Recognizing these aspects helps us think about sustainable practices and conservation. Overall, this slide connects the dots between different energy sources and minerals, emphasizing their significance in industrial development and energy security. It sets the stage for exploring how these resources are distributed, mined, and used in our daily lives. When we look around, we see a variety of materials like diamond, limestone, fluoride, and aluminium. These are all examples of minerals. Minerals are naturally occurring substances that have a specific internal structure, which means their atoms are arranged in a particular way. Geologists define minerals as homogeneous, naturally occurring substances with a definable internal structure. This internal structure gives minerals unique properties and makes them useful for many purposes. Minerals come in different forms and are essential in our daily lives, from jewelry to construction, and even in our health products. Understanding minerals helps us appreciate their role in the world and how they contribute to various industries. Rocks are essentially a mix of minerals and impurities. When we talk about what makes up a rock, it's not just pure minerals. There are often other materials mixed in. A single rock can contain just one type of mineral, or it can be a combination of several different minerals. Interestingly, even though over 2,000 minerals have been discovered so far, only a handful are actually common in most rocks. This is important because it shows how diverse minerals are, but also how certain minerals tend to dominate in typical rocks. Understanding this helps us see how rocks are formed and why they have the characteristics they do, which ties back to our overall exploration of Earth's geology. Sedimentary rocks often display these characteristic flat, thin, and parallel layers known as beds. These beds are formed when sediments are deposited in a series of flat, thin layers. Over time, these layers get buried under additional sediments, which causes compression. The minerals in the sediments then cement these layers together, turning them into solid rock. It's interesting to note that each individual bed can be easily distinguished from its neighbors. This is because they often show slight differences, such as in grain size, which could be finer or coarser, or in how resistant they are to weathering. Sometimes, the coloration varies as well, giving each bed a unique look. These features, these beds, are really important because they tell us about the environment and conditions under which the sediments were deposited. Recognizing these layers helps us understand the history recorded in sedimentary rocks, which ties back to our overall theme of how Earth's surface processes shape the landscape. Ores are essentially accumulations of minerals that are mixed with other elements. They serve as the primary source from which we extract valuable minerals. The key point here is that minerals are not usually found in pure form. Instead, they are embedded within these ores. To get the minerals we need, we apply various extraction processes. It's important to highlight that the mineral content within the ore must be high enough, meaning in sufficient concentration, for the extraction to be economically viable. If the concentration is too low, the process might not be worth the cost or effort. This concept ties into the overall theme of resource management and efficient extraction in mining. Understanding ore composition helps us optimize our methods and ensure sustainable, profitable mineral production. Now let's look at the various ways minerals occur in nature. First, minerals can be found in a diffused form, such as salts, magnesium, bromine, and similar substances spread throughout the Earth's crust. Next, in our oceans, minerals are often present as alluvial deposits, which are also called placer deposits. These are concentrations of valuable minerals like gold, silver, tin, and platinum that have been deposited by water action over time. We also find minerals in the sands of valleys, where they accumulate naturally. Additionally, minerals occur as residual masses that contain ores. An example of this is bauxite, which is the primary ore for aluminum. Moving on, minerals can form beds and layers due to processes of deposition and accumulation. This is how we find coal, iron ore, gypsum, and sodium deposits. These layers are often the result of long geological processes that concentrate these minerals over time. In sedimentary rocks, minerals are deposited as part of the rock formation process. These rocks often serve as important mineral reservoirs. Then we have the decomposition of surface rocks, which can lead to mineral-rich materials. Over time, weathering breaks down rocks, releasing minerals into the soil and surrounding environment. Cracks, crevices, faults, or joints in rocks, these are called veins or lodes, are also significant. Minerals like zinc, copper, and lead often fill these spaces, forming concentrated deposits that are vital for mining. Finally, minerals can be found in igneous and metamorphic rocks, which form under high temperature and pressure conditions. These rocks are often rich sources of various minerals, making them crucial for exploration and extraction. So, understanding these different occurrence patterns helps us locate and extract the minerals we need for various industries and applications. Let's take a closer look at the Peninsular Plateau. This region is quite rich in various minerals, including coal, metallic minerals, and non-metallic minerals. The Peninsular Plateau is one of the oldest landforms in India and has significant mineral resources that support many industries. Moving on, Rajasthan is particularly famous for its non-ferrous minerals. These include minerals like gypsum, phosphorite, and mica. Rajasthan's mineral wealth plays a crucial role in the state's economy and industrial development. Next, we have Gujarat and Assam, which are notable for their petroleum deposits. These states are important contributors to India's energy sector, with Gujarat being a major hub for oil refining and Assam for its significant oil fields. This distribution of minerals across different regions highlights how diverse and resource-rich India is. It also emphasizes the importance of understanding regional geology to effectively harness and manage these mineral resources. A mine is essentially a large area that contains a significant amount of mineral deposits. When we talk about mineral deposits, we're referring to concentrated accumulations of valuable minerals that can be extracted. The key point here is that these deposits are not just present, but they're also accessible in a way that allows for easy and economical extraction. This means that mining operations can be efficient and profitable when these conditions are met. Understanding what makes a site a viable mine helps us appreciate how natural resources are brought from the earth to meet our needs. This concept ties into the overall theme of resource extraction and how we utilize the earth's materials responsibly. Now, moving on to ferrous minerals, which include important elements like iron and manganese. These are examples of ferrous minerals that are crucial for our industry. In fact, ferrous minerals make up about 3/4 of the total value of metallic mineral production. That's a significant share, highlighting their importance in the mineral sector. They form a strong foundation for the development of metallurgical industries, which are vital for manufacturing and infrastructure. India not only meets its internal demand for these minerals, but also exports substantial quantities to other countries. This export capacity underscores our country's rich mineral resources and the role they play in our economy. So, understanding ferrous minerals helps us appreciate how they support industrial growth and international trade. Let's take a closer look at some of the common iron ores we encounter. Hematite, for example, contains about 50 to 60% iron content, making it a significant source of iron. Magnetite, on the other hand, has a higher iron content, around 70%, which makes it even more valuable for iron extraction. India is quite fortunate in this regard because we are rich in iron ore deposits. This abundance plays a crucial role in supporting our steel industry and overall economic growth. As we explore ferrous minerals, it's important to recognize that iron ore is a major component, and its availability has a direct impact on our industrial development. Let's start by looking at some other important minerals and industrial products. First, paints and bleaching powder are produced in India, with Orissa being the largest producer of bleaching powder. Moving on to insecticides and steel, both are critical industries supported by our mineral resources. Now, a key mineral used extensively in manufacturing is manganese, which falls under the category of ferrous minerals, specifically manganese. Focusing on ferrous minerals, iron ore is the backbone of industrial development in India. Fortunately, India is endowed with abundant and good-quality iron ore resources. There are two main types of iron ore, magnetite and hematite. Magnetite contains about 70% iron content, and it's prized for its excellent magnetic qualities, making it valuable in electrical industries. Hematite, on the other hand, has about 50 to 60% iron content and is the most widely used industrial iron ore due to its large-scale availability. India's major iron ore belt spans several regions. In the Orissa-Jharkhand belt, high-grade hematite ore is found in the Badampur mines of Mayurbhanj and Kendujhar districts. Jharkhand's Singhbhum district, including Gua and Nomundi, is also significant for hematite mining. In the Durg-Bastar-Chandrapur belt across Chhattisgarh and Maharashtra, very high-grade hematite is mined from the Beldilla Range in Bastar. This range contains 14 deposits of super high-grade hematite iron ore, which have ideal physical properties for steel making. Most of the iron ore from these mines is exported to Japan and South Korea through the Vishakhapatnam port, supporting international steel industries. Further south, the Bellary-Chitradurga-Chikmagalur-Tumkur belt in Karnataka is another major iron ore region. The Kudramukh mines in the Western Ghats are particularly notable. They are among the largest in the world, and the ore is transported as slurry through pipelines to a port near Mangalore for export. Finally, in the Maharashtra Goa belt, iron ore is mined in Goa and the Ratnagiri district of Maharashtra. While these ores are not of the highest quality, they are still efficiently exploited and exported through the Marmago port, contributing significantly to the industry. These regions and their resources form a vital part of India's mineral wealth, fueling our industrial growth and exports. India's reserves and production of non-ferrous minerals are unfortunately not very satisfactory. When we talk about these minerals, we're referring to important resources like copper, bauxite, lead, zinc, and gold. These minerals are incredibly vital because they play a key role in various industries such as metallurgy, engineering, and electrical manufacturing. Without sufficient reserves and production, our ability to meet industrial demands can be limited, which in turn affects economic growth. This highlights the need for us to explore better ways to develop and manage these non-ferrous mineral resources to support our industrial development and technological progress. Let's talk about some of the important copper-producing areas in India. Singhbhum in Jharkhand and Khetri in Rajasthan are notable for their copper production. These regions play a crucial role in meeting the country's demand for this metal. Now, among all the copper mines in India, the largest producer is the Balaghat mines in Madhya Pradesh, which accounts for about 52% of the entire country's copper output. That's quite significant, emphasizing how central this mine is to India's copper industry. Copper is used in many essential industries. You'll find it in electrical cables because of its excellent conductivity, in electronics for various components, and in chemical industries for different processes. Its versatility makes it a highly valuable metal. However, it's important to note that India is actually deficient in copper, meaning we need to import a good portion of what we use. Copper has some unique properties. It's malleable, which means it can be hammered or rolled into thin sheets, and ductile, so it can be drawn into wires easily. These qualities, along with its excellent conductivity, make copper indispensable for electrical and electronic applications. So, understanding copper's production, uses, and properties helps us appreciate its significance in India's economy and industrial development. Bauxite is an important ore because it is the primary source of aluminium, which is widely used in various industries. You can find bauxite in specific regions like the Amarkantak Plateau, the Makel Hills, and Katni. Among these, Orissa stands out as the largest producer, accounting for about 45% of the total bauxite production in the country. Interestingly, Koraput in Orissa not only contributes significantly to production, but also holds the largest reserves of bauxite in India. This highlights the area's strategic importance in our mineral resources. So, understanding the distribution and reserves of bauxite helps us appreciate how mineral resources are vital to our economy and industry development. Let's take a look at some of the key locations where mica is found. You can see that major deposits are located in Koderma, Gaya, and Hazaribagh in Jharkhand, as well as Ajmer in Rajasthan and Nellore in Andhra Pradesh. These regions are rich in mica deposits, which are crucial for various industries. Now, what exactly is mica? Well, mica is a mineral composed of a series of thin, flat plates. It naturally splits into very thin sheets, which makes it quite unique. Mica can come in a variety of colors, including black, green, red, yellow, and brown, adding to its versatility. One of the most important qualities of mica is its excellent dielectric strength. This means it can withstand high voltages without conducting electricity, making it ideal for electrical applications. It also has low power loss and good insulation properties, which are essential for electronic devices. Additionally, mica is resistant to high temperatures and high voltage, making it a reliable material in the electric and electronics industries. Its insulating properties help protect delicate electronic components, ensuring safety and efficiency. So, in summary, mica's physical properties and location make it a vital non-metallic mineral in modern technology. Its unique characteristics are what make it so valuable in various electrical and electronic applications. Limestone is primarily found in calcium carbonate sedimentary rocks, which are quite common in nature. It plays a crucial role in various industries, especially in the cement industry where it's a key raw material. Additionally, limestone is used in iron smelting processes, contributing to steel production. When we look at the major producers of limestone in India, Andhra Pradesh, Madhya Pradesh, and Rajasthan stand out as the leading states. These regions have abundant limestone deposits, which support their industrial activities. Understanding where limestone is found and how it's used helps us appreciate its significance in our overall discussion on rock minerals and their economic importance. Let's take a closer look at the different types of minerals. As you can see, they are generally categorized into three main groups: metallic, non-metallic, and energy minerals. Starting with metallic minerals, these include both ferrous and non-ferrous types. Ferrous minerals contain iron, such as iron itself, manganese, chromite, pyrite, tungsten, nickel, and cobalt. These are crucial because they are used extensively in manufacturing and construction. Non-ferrous minerals, on the other hand, include metals like gold, silver, copper, lead, bauxite, and magnesium. These are valued for their resistance to rust and corrosion, which makes them vital in electrical wiring, jewelry, and various industrial applications. Moving to non-metallic minerals, these are typically used in construction, agriculture, and industry. Examples from our table are limestone, nitrate, potash, dolomite, mica, gypsum, and bauxite. They often serve as raw materials for manufacturing cement, fertilizers, and other products. Finally, we have energy minerals. These are essential for powering our industries and households. Coal and petroleum are the most prominent, but natural gas and gypsum also fall into this category. These energy sources fuel our daily lives and support economic development. Connecting this to the overall theme, understanding these different mineral types helps us appreciate their diverse roles in modern life, from building infrastructure to powering our homes. Recognizing the variety and importance of these minerals is key to sustainable resource management and economic growth. Let's talk about some of the hazards associated with mining. First, land degradation is a major issue. When land is dug deep for mining, it often becomes unsuitable for any kind of future use once the mining activity stops and the site is abandoned. This not only affects the environment, but also the local communities that depend on healthy land. Next, there's the danger to miners themselves. Inundation or flooding can occur suddenly, and fires in mines are also a serious threat. Additionally, the collapsing of mine roofs can be life-threatening, making mining a risky occupation. Mining activities also have a significant impact on water sources. Waste and slurry from mining can contaminate nearby water bodies, which can harm aquatic life and pose health risks to people relying on that water. And let's not forget about health issues for miners. Dust and noxious fumes generated during mining can lead to pulmonary diseases, affecting the respiratory health of those working underground. So, as we see, mining presents a range of environmental and safety hazards that we need to carefully consider and address. Minerals are a limited resource, which means they are finite and cannot be replenished quickly. If we don't use them wisely, they will eventually run out. Interestingly, only about 1% of the total mineral deposits are actually accessible for us to use. This highlights how much of these resources remain hidden or difficult to extract. Remember, mineral formation is an incredibly slow process, taking thousands or even millions of years. That's why it's crucial that our rate of consumption doesn't exceed the rate at which these minerals are naturally replenished. Conserving minerals isn't just about saving resources for future generations. It's about ensuring the sustainability of our environment and our economy. By managing our mineral use responsibly, we help protect these vital resources and support the overall health of our planet. Let's take a closer look at energy resources, which are fundamental to our daily lives and development. On this slide, we see a comparison between conventional and non-conventional sources of energy. Conventional sources include firewood, cattle dung cake, coal, petroleum, and natural gas. These have been used for a long time, and they form the backbone of our energy consumption. For example, firewood and cattle dung are traditional sources used mainly in rural areas, while coal, petroleum, and natural gas are more common in urban settings and industries. However, these sources are limited, and their use has environmental impacts, such as pollution and contributing to climate change. That's where non-conventional sources come into play. They include solar energy, wind energy, tidal energy, geothermal energy, biogas, and atomic energy. These are more sustainable and eco-friendly options. Solar energy harnesses sunlight, wind energy captures the power of moving air, and tidal energy makes use of ocean tides, each offering renewable options. Geothermal energy taps into the heat beneath the Earth's surface, while biogas is produced from organic waste. Atomic energy, or nuclear power, provides a large amount of energy from a relatively small amount of fuel. Connecting this to the overall theme, diversifying our energy sources and shifting towards non-conventional options is essential for sustainable development and reducing environmental impact. It's about balancing our current needs with the health of our planet for future generations. Did you know that in rural India, about 70% of their energy needs are met by firewood and cattle dung cakes? It's quite significant, isn't it? These traditional sources have been relied upon for generations. However, we're seeing a shift happening. Continuing with these sources is becoming increasingly difficult. Why? Because forest areas are shrinking, which means less firewood is available. Plus, dung cakes are being discouraged because they take away the manure that's so vital for agriculture. So this highlights a crucial challenge. How do rural communities meet their energy needs sustainably without depleting forests or compromising their farming? It ties into the bigger picture of how we classify and think about different energy resources, which we'll explore next. Let's talk about coal, which is the most abundantly available fossil fuel in India. You'll find it mainly in the Damodar Valley, which is in West Bengal and Jharkhand. That region is rich in coal deposits, and some of the most important coal fields there include Jharia, Raniganj, and Bokaro. Besides these, coal is also found in other states like Meghalaya, Assam, and Arunachal Pradesh, among others. Now, coal isn't just one uniform type. There are different kinds, each with unique qualities. The highest quality coal is called anthracite. It's very hard, has a high carbon content, and burns cleaner and hotter. Then we have bituminous coal, which is the most commonly used type of coal. It's mainly used in industries like iron smelting, where it's burned in blast furnaces to extract metal. And finally, there's lignite, which is considered low-grade brown coal. It's softer, has a lot of moisture, and is less efficient as a fuel. An example of lignite is found in Neyveli in Tamil Nadu. Understanding these types helps us see why coal remains such an important resource in India's energy and industrial sectors. Now, let's look at the distribution of petroleum resources across India. About 18% of the country's petroleum comes from the Ankleshwar oil field in Gujarat. This highlights Gujarat's significant contribution to India's oil production. Moving on, Digboi in Assam is notable because it is the oldest oil field in India, marking the beginning of the country's oil industry. A major portion, around 63%, of India's petroleum is produced from the Mumbai High offshore oil field, which is one of the largest and most productive offshore fields in the region. Additionally, about 16% of India's petroleum comes from other important fields in Assam, including Digboi, Naharkatia, and Moram, Hugrajan. These fields are found in rocks from the Tertiary Age, which is a crucial geological period for oil formation. Overall, these points show how India's petroleum reserves are geographically distributed and how different fields contribute to the country's energy needs. Now, let's talk about how natural gas is transported and used. One of the key methods is through pipelines. For example, the Hazira, Vijaypur, Jagdishpur pipeline is the longest pipeline in India, stretching about 1,700 kilometers. It carries natural gas from Hazira in Gujarat all the way to Jagdishpur in Uttar Pradesh. This pipeline plays a crucial role in distributing gas efficiently across regions. Natural gas is found in various regions such as the Krishna Godavari Basin, the Gulf of Cambay, the Andaman and Nicobar Islands, and the Mumbai High offshore area. These locations are important sources that supply the gas we use daily. Speaking of usage, natural gas is commonly used as CNG, compressed natural gas, in vehicles. It's a cleaner alternative to traditional fuels, which helps reduce pollution. In fact, natural gas is considered environmentally friendly because it produces very low carbon dioxide emissions compared to other fossil fuels. So, to sum up, natural gas is transported through extensive pipeline networks, sourced from rich reserves, and used as a clean fuel option, contributing to a more sustainable environment. Electricity can be generated through various sources. One common method is by burning fossil fuels like coal, petroleum, or natural gas. This process involves burning these fuels to produce heat, which then generates steam that drives turbines to produce electricity. Another important source is hydroelectricity, which harnesses the force of moving water. For example, the Bakra Nangal and Damodar Valley projects use water flow to generate power, turning the kinetic energy of water into electrical energy. Both these methods are crucial in our energy landscape. While fossil fuels are widely used, hydroelectricity offers a cleaner alternative by utilizing natural water cycles without emissions. Understanding these methods helps us appreciate how diverse our electricity sources are and highlights the importance of balancing different energy options to meet our needs sustainably. India has 6 nuclear power stations spread across different states. These include Kakrapar in Gujarat, Kaiga in Karnataka, Tarapur in Maharashtra, Kalpakam in Tamil Nadu, Narora in Uttar Pradesh, and Rawatbada in Rajasthan. These facilities play a vital role in our country's energy production. It's also important to understand where the key raw materials for nuclear energy come from. Uranium and thorium, which are essential for nuclear power, are mainly found in states like Jharkhand, Rajasthan, and Kerala. Now, how do we generate nuclear energy? It's obtained through the process of nuclear fission, which involves splitting radioactive elements such as uranium and thorium. This process releases a huge amount of energy, which is then harnessed to produce electricity. So, in summary, nuclear energy is a significant part of our energy mix, relying on specific locations for reactors and raw materials, and driven by the process of nuclear fission. When we talk about the maximum potential for solar energy in India, Rajasthan and Gujarat stand out as the leading states. These regions have some of the best sunlight conditions, making them ideal for harnessing solar power. Solar energy, as many of you know, can be converted into electrical energy using photovoltaic technology, which is essentially solar panels that capture sunlight and turn it into electricity. In fact, India's largest solar plant is located in Madhapur, Gujarat. This plant showcases the scale at which we can harness solar power and highlights the country's commitment to renewable energy. Being a tropical country with abundant sunshine throughout the year, India has enormous potential for solar power development. This potential is a crucial part of our overall energy strategy, helping us reduce dependence on fossil fuels and move towards a cleaner, more sustainable future. So, harnessing solar energy is not just about individual solar panels, but about tapping into a vast resource that can significantly impact our energy landscape. Let's talk about wind power in India. States like Andhra Pradesh, Maharashtra, Gujarat, and Kerala have huge potential for tapping into wind energy, thanks to their favorable wind conditions. When we look at the biggest wind farm clusters, the largest is definitely in Tamil Nadu, which has a significant concentration of wind power installations. Additionally, places like Nagarcoil and Jaisalmer are notable for their large wind farms, contributing substantially to our national capacity. Overall, India is truly a wind superpower. Our country is harnessing wind energy effectively, positioning us as a leader in renewable energy. This underscores the importance of expanding and optimizing wind energy projects as part of our broader goal for sustainable development. Gobar gas plants are established in rural areas where they play a crucial role in managing organic waste. These plants decompose waste such as crop leftovers, animal manure, and even human waste to produce biogas. This biogas is a valuable source of energy, mainly used for domestic purposes like cooking and lighting. Additionally, the process generates manure, which farmers can use to enrich their fields, boosting agricultural productivity. Compared to traditional fuels like firewood, dung cakes, and kerosene, gobar gas is much more efficient and cleaner. It reduces the reliance on these conventional fuels, which can be harmful to health and the environment. Most of this biogas is used directly in rural households, making it a sustainable and accessible energy source. It's produced from farm waste, animal waste, and human waste, making it a very eco-friendly solution that also helps manage waste effectively. So, in essence, biogas technology not only provides an alternative energy source, but also supports sustainable farming and waste management in rural communities. The Gulf of Kutch in Gujarat is actually a region with tremendous potential for tidal energy. When we talk about tidal energy, we're referring to the power generated by the movement of ocean tides. Essentially, the energy of these oceanic tides can be harnessed to produce electricity, which makes it a promising renewable energy source. This slide highlights how tidal energy can contribute to our overall energy mix, especially in coastal areas like Gujarat, where the tides are quite strong. It's exciting to see how natural phenomena like tides can be transformed into sustainable power, helping us reduce reliance on fossil fuels and move towards cleaner energy solutions. Let's take a look at some exciting geothermal projects in India. For instance, Manikaran in Himachal Pradesh and Puga Valley in Ladakh are notable for their geothermal power initiatives. These locations harness the Earth's internal heat to generate electricity, showcasing the potential of geothermal energy in our country. India's hot springs, like those in Manikaran and Puga Valley, are ideal sources for this type of energy. They provide accessible and sustainable thermal energy, which can be converted into electricity. Now, to clarify what geothermal energy really is, it's the energy produced by utilizing the internal heat of the Earth. This heat originates from the Earth's core and is stored beneath the surface. When we tap into this heat, we can generate a reliable and eco-friendly source of power. So, in summary, geothermal energy leverages the Earth's natural heat, and India has promising sites like Manikaran and Puga Valley that are leading the way in this sustainable energy development. As concerned citizens, we all have a role to play in conserving energy. We can start by using public transport instead of relying on our personal vehicles, which helps reduce pollution and energy consumption. When we're not using electricity, it's important to switch off lights and appliances to avoid wastage. Additionally, choosing power-saving devices can make a significant difference in our energy use. Opting for non-conventional sources of energy, like solar or wind power, is also crucial for a sustainable future. Let's remember that India is currently one of the least energy-efficient countries in the world. This highlights the urgent need for us to adopt a cautious and responsible approach to using our limited energy resources wisely. Developing a sustainable energy path is essential, and this involves promoting energy conservation alongside increasing our use of renewable energy sources. These two strategies are the backbone of sustainable energy development. Energy is fundamental for our country's economic growth. It fuels agriculture, industry, transport, and our everyday domestic needs. As our energy consumption continues to rise across all sectors, it becomes even more important to manage and conserve our resources effectively. By doing so, we ensure that energy remains available for future generations and that our development remains sustainable.